Good day, everybody. Randy Franklin Smith here, and today we are going to have a lot of fun. We are going to look at another way to control root access, and it's pretty neat and opens up a lot of possibilities. And the cool thing is BeyondTrust takes this capability that's in Linux and just really puts it on steroids. Paul, the same way that you put Sudo on steroids, if you don't mind me characterizing PowerBroker that way. Let me introduce you to Paul Harper, folks, from BeyondTrust.
All right, thanks, Randy. Yeah, that's exactly it. And we're gonna once you're done with your, I guess more than an intro, I'll be happy to show what it actually looks like inside of the product.
All right, great. Let me ask you folks just a real quick question, real quick poll, and then we'll get the show on the road in earnest. But where's your company right now in terms of your privileged account management, least privilege, AD bridging, and stuff like that? Folks are coming in and voting. Just give it a couple more seconds here. Thanks for giving us feedback, folks. It helps us with our planning. I had a lot of fun developing this one, Paul. I'm glad you brought it to me. I'll be honest and say I did not know about this capability in Linux beforehand, but this taught me a whole lot, and I've actually implemented it with a little shell that I put around. Well, I don't want to give away what I'm going to do yet, so you'll see here shortly. But we're going to do some LD preloading. All right, I'm going to close the poll. Thanks a lot for giving us that feedback. Now, we're going to start out with just talking about the what I call very monolithic authority structure in Linux, that you're basically, at the beginning of time, it was your root or your nothing. And then Sudo came along, but then we're going to be honest about some of the realities of Sudo and talk about what is another way that we can control root authority. So Sudo is all about controlling what users can enter on the command line, and it's all about saying what root things can they do, what root commands can they run as root, I should say, whereas we're going to take it from the opposite direction and say, okay, what if we give somebody root access? What can we prevent them from doing? But there's more to it than that, so let's jump into it. So like I said, at the beginning of the time, when Linux was, well, Unix, and even going back to Multics, you were either an end user or you were super user. You were root, and that was it. And Linux and Unix are basically built like this. They assume that the system administrator, root, knows exactly what he or she is doing, and because of that, there's virtually no safety net for root. How do you feel about that as a characterization of Linux, Paul?
Yeah, I think there's one user and then there's everyone else, right? So there's that. We always refer to root being the God user because you have godlike power. And you're right. There's Linux has got a little bit more user-friendly. When you go to delete files, if you omit certain switches, it will warn you. But of course, most Linux admins quickly figure out, like -F to force a deletion, saves that prompt. But then also, as we've all done at one point or another, you end up deleting a whole bunch of stuff that you don't mean to. So, yeah, it's a powerful user for sure.
So then came Sudo, and I guess Sudo has its roots back in the 80s. I didn't realize that, but I researched it some, and that's what I came up with. Basically, this allows us to define sub-administrators, and we've done quite a few webinars on Sudo. If any of you haven't seen those and you're new to Sudo, please check out my webinar library back at Ultimate Windows Security, and you'll be able to find those. But it basically allows us, it's least privilege for Linux and Unix. So we can get very granular in specifying which commands different users can run, and even which arguments on those commands that they can specify. I'll give you a real quick example. There's the service control command that allows you to stop, start, restart services. So we can make up rules in the sudoers file that say, okay, you can run system control, but only for starting or stopping the printer service, but not the network service, for instance. So that's great. And Sudo also provides an audit trail. So you see there, instead of the user running commands directly, they just put sudo in front of it. So now sudo takes over. And the first thing sudo does is checks your identity and what you want to run against the sudoers file. And if everything checks out, then it goes ahead and runs that command as whatever user, and typically that is root. But at the same time, it's creating a log and a session recording. It's almost like a video. And that way we now have both least privilege and granular control over what subadmins can do, but we also have accountability and an audit trail over them. So that all sounds great, and it is. I mean, you know, you shouldn't try to run an enterprise Linux environment without using sudo. But there are some realities with it, right? Everything has its limitation. Number one, sudo is not centralized, and so you've got the sudoers file out there on every Linux system, and if you have multiple distros of Linux, then that makes it more fun. You know, it just kind of goes on from there. It quickly can become very unwieldy to try to use sudo in a multiple system environment. So that's just one thing. But also, the sudoers file is laborious and tricky to get right. I mean, I'm not saying you can get used to the syntax of the sudoers file and how all of that works, and you can use command aliases and user aliases and all of that. But, you know, Paul, what we're dealing with is trying to dictate what people can type on the command line and what they can't. And there's also so many different ways to skin the cat in Linux, and it's very easy to set up some sudo rules that will prevent a newbie from doing something you don't want them to do, but someone who knows more about Linux can oftentimes find a way around it unless you yourself are a Linux expert and have thought of every conceivable route and controlled it in Linux. Thoughts on that?
Yeah, I mean, we've done sessions on sudo in the past, so I won't talk in too much detail on that. But it's you're right. It's a for more Windows people, it's I guess the equivalent of right-click run as administrator, although it doesn't prompt you for the administrator's password. You actually potentially need your own password to verify yourself as a user. But yeah, it's a set of rules that if implemented correctly, allows those basic users, remember going back to what you said at the beginning, where you have the root user, the God user, and everybody else. So it allows everybody else to run certain things at a higher privilege level, but focusing on what they type on the command line.
And you know, I would just have to say that I would regard run as in Windows more like SU in Linux, and the ability in Windows, you can grant out granular authority to like do this, load device drivers or not, or you know, start services or stop services. I would compare that more to sudo. But anyway, this webinar isn't about sudo, but we do have to make a few points to help about sudo to help demonstrate the need for what we're going to show. And what it comes down to that it takes a lot of work to define exactly what each admin can do, because you have to go beyond commands and get into arguments and the arguments on those commands. And it's very easy to not think about stuff that's just unforeseen. So then, the next question is, well, why don't we just do a permit all, but then define exceptions? So you can do that. You can use the command alias all and say, okay, you could create an admins group and just say, okay, admins have all, but here are some exceptions, some denies, like explicit denies in sudoers, and you do that with the exclamation point. But as soon as you start doing that, you realize that there's always going to be ways around it. And this is a fascinating article that just talks about how hard it is to say, look, somebody can use the service control command to restart any service except for this particular service, the network service. And it's a fascinating read if you're interested in this kind of thing. So that's basically not an option, is my point, just saying permit all and then defining exceptions. So what we find is at the end of the day, a lot of organizations will use Sudo to limit some of their admins, but then for a lot of other admins where they just can't really get a handle on everything that admin may need to do. I mean, maybe that admin basically needs to do just about anything if the problem calls for it. And so we end up giving all to them, command alias all, and then basically saying, well, we're going to have to trust these people and rely on auditing as an accountability and deterrent control. All right. Well, we are still way ahead of the game by using Sudo because we have that auditability and accountability. But that still opens things up. There's a lot of bad stuff that either a disgruntled, malicious admin could do, or remember, it's not always about the insider, right? Root credentials get stolen all the time. And so that's a thing too. So how can we still implement some control even for folks that basically have root authority? That's what we're going to talk about today. The other thing is that Sudo specifies what you can do at the command line. It's all about the command line. Sudo does not control what executables can do, what binaries can do. And that's something you have to be careful of, by the way, like with VI, the editor. VI normally can shell out and run commands right from VI. So if you give somebody in Sudo the authority to run VI, you have to take additional measures to make sure they can't shell out and run arbitrary commands and thus bypass Sudo. That's just one example of what I'm talking about when I say that Sudo controls what happens at the command line, but not what executables can do. And sometimes what you want to control isn't a command, but maybe it's something about a particular file or router tables or stuff like that. So let's flip this around. We're not saying don't use Sudo, because I mean, after all, I've done all these webinars about Sudo, and BeyondTrust, has their awesome PowerBroker solution, which I've called Sudo on steroids. But in addition to that, or for the folks that have to have root access, let's flip it around. Let's take somebody who has root access, but still implement some restrictions on what they can do and get auditing on what they are doing. And let's do this not at the command level, but instead at the system call level or other calls to basically enter any other library. That is at least what this feature of Linux can do that I'm about to show you. So first of all, what are system calls? System calls, to me, are a lot like the Win32 API in Windows. System calls are the entry points to the kernel. That's when an application needs to actually do something through the operating system, which ultimately everything comes down to kernel operations, right? Whether you're opening a file or sending a packet out on the network. This is accomplished through a syscall to the kernel. Now, there's a little wrapper around most of those function calls, and a lot of those wrappers are in glibc, which is just the standard library of the C programming language, which is closely tied to Linux. And so whether you are in the shell doing something or whether you're an executable, let's say we're going to read 100 bytes from a file. Well, that may be accomplished through the function call, fread or whatever it is. I can't remember at the moment. That hits your standard library of C, but that in itself is just a wrapper for the syscall of the kernel where the operating system finally gets involved and actually goes out to that place on disk and reads that data in. So syscalls, they're the APIs into the kernel is another way that you could put it. And the cool thing is there may be a million ways to do something at the command line, but it's going to come down to a finite set of system calls. And so syscalls, I'd like to say that they are a great choke point for implementing security checks and auditing. Paul, do you have any thoughts to share on that?
I must apologize. I was actually answering some questions that were coming into the webinar, so I wasn't.
I'm just talking about syscalls. I'm sorry to throw the ball at you unawares. I just, syscalls to me are like that. They're just a wonderful choke point for catching certain operations and knowing that you've caught that operation regardless of where it's come from, whether it's something I did in a script, whether I did it in Perl or Python or from C or whatever. You know what I mean?
Yeah, I think my one-liner for this is basically a system call is what your host, your system, your operating system is about to do, not what you typed at the command line. Because I think anybody that's even got some basic Unix Linux knowledge knows that it's possible. Symlinks are probably the most common thing, right? A shortcut is another way of thinking about it. Is you can name a shortcut or a symlink to anything you like. But ultimately, what the system's going to do, like if you were to make a symlink to, I don't know, the RM command and call it Randy, when you type Randy at the command line, you don't necessarily think of deleting files, but that would effectively be what would happen if you link the two together. So I always talk about system calls being what's actually going to happen as opposed to what the user typed.
Yeah. And somebody thought, hey, are we bashing Sudo? So I didn't want to give that impression. And I think I said that, right? I mean, no system is complete, no Linux environment is complete if you're not using Sudo, but every technology has its limitations. So that's kind of the direction we're coming from on that. Okay, so syscalls, great choke point then for controlling what's going on. But the question is, how do you intercept a system call? And then how do you re-implement it? Or how do you just wrap additional functionality around it? Maybe I just want to audit what's happening. How do you perform a check and then say, no, I don't want this system call to go through, so we just want to cancel it? Well, we get to do all of that through the use of LD preload. And Simon says, so what are we talking about? Is it something that requires recompiling the kernel? No. This is all stuff that is just built into Linux. We're not doing anything that's not supported. In fact, I think you'll be amazed when you see, in some ways, how easy it is, not to take away from what you guys have built, Paul, but it's a fully supported feature of Linux. Fair enough, LD preload.
Oh, absolutely. Yeah, there's lots of uses, that not just BeyondTrust. I mean, we make use of an LD preload, which we're going to get into, towards the end of this webinar. Other software vendors use LD preloads for other functions. I know that sounds really generic, but you can, as a Unix Linux user, you can obviously make your own, as you know, Randy, because you've done that, and I know you're going to get into it. So it's the uses are more than just enhancing security. You can do fun stuff. You could potentially do bad stuff as well. But again, we're just talking about well, we're focusing more today on using LD preloads to improve the security of the host or allow you to do, I guess, stuff to enhance those security controls that you put in place, such as, you know, Sudo, or even in our case, our least privileged tool.
Yeah, so LD preload to me is, I would characterize it as a hook or user exit where you can enhance, modify, or, you know, otherwise wrap additional functionality around interaction with the kernel. So to understand LD preload, we need to add a little bit more background. For those of you coming from a Windows world, we need to understand relocatable libraries, or shared libraries, they're called in Linux. So folks, you know, in Windows you have DLLs, which stands for dynamically linked library, meaning that when we compile the program, we don't put the code in that library into the exe. Instead, when the exe loads, the operating system says, oh, you need Win32.this or this DLL or that, and it goes ahead and loads that up if it's not already in memory, and then it looks for where your program calls functions in that library and maps things around so that those entry points can be found by your code. So Linux does very much the same thing, but in Linux, instead of being called DLLs, they're called shared libraries, and they have a .so extension on the file. So a .so file, to me, is a lot like a dynamic DLL in Windows. And in Linux, the dynamic linker, that part of Linux that does all of this, is called LD. So when you run an executable in Linux, LD figures out what shared libraries the exe uses and what function calls it imports, and it links everything up. But the interesting thing is that the function names that your program, that your exe, or I should say your executable calls, are not tied to the library they belong to. They're not coupled together in Linux. So it all, you know, if more than one library implements the same function call, then it all depends upon what order the libraries are called in, and so, or loaded, linked in. And so if, quote unquote, my program calls do this and two libraries implement do this, then the first library linked is the one whose do this is going to be executed. Now, normally that order is determined by LD and the executable. There's a nice choreographed way that it all takes place, and that uncertainty is eliminated unless we specify something with the LD preload environment variable. So LD preload, simply an environment variable that lists one or more shared libraries to load before any others. And so when you run an executable, the first thing LD does is look at the LD preload environment variable and says, oh, let me load up these libraries first and resolve any function names that they implement that the executable uses, and then we'll load up the rest of the libraries. You can, by the way, specify these libraries, if there's several of them, by just delimiting them either with a colon or a space. And so what this allows us to do is selectively override functions in other shared libraries. Whatever functions you implement in the preload libraries are going to get called instead of the normal implementations. Now, I'm going to show you a little demo, and I just want you to know I got this from this really cool guy, Rafal, who wrote it, and it is so short but compelling. It's really cool. So let me take you over there. All right, so here's my Kali Linux box, and I wrote, or I should say Rafal wrote this little program, and a lot of you can probably look at it and see what it does, but we are seeding a random number generator, and then we're looping 10 times, and we're simply printing out a random number. So Paul, what would you expect to get here? Just 10 random numbers, right? Well,
I would expect it to be random for sure.
Let's see what happens. So
I could have
now,
spoiled your demo as I do kind of know the answer, but
yes,
I'm not going to do that.
Thank you for being my shield and playing along.
That's right.
Let's see here. I got to make sure I've got the right. Well, in fact, you know what? I'll show it to you first this way. So let's run it. Let's type in the right command first. There. That's not very random. The same number 10 times in a row, and it's not just any number, it's a number pretty familiar to geeks. So what in the world happened? Well, let's look at my environment variables, and we'll go up here and look at LD preload. I have a shared library being loaded called unrandom.so. See if we can find the source code for that. Sure enough. What does unrandom.so do? Randy, come on, think. People don't want to see binary code. There you go. Look at this. All it does is implement that same function call, rand, and returns the static number 42 every time. And that is all it took for us to change, this part of the kernel, or at least, the C standard library. Now, hopefully, folks, you understand how that works, but here's just a visual. So normally, my random num program, when it calls rand, is going to get that out of libc, which is the standard library of C, and it's going to give us back a normal random number, or at least as the best that our random number generator can do. But with LD preload, unrandom.so gets loaded first. LD says, oh, you implement the rand function. Well, I'm going to map calls in random num over there to that, and that's how it works. So, of course, this is just a fun example, but that should show you how we get to do some pretty neat stuff. I'm going to come back to this slide in a second. So that allows us then to re-implement. That's what I did. I just completely re-implemented the function because I don't even call it. But what could we have done? If we, for some reason, wanted an audit trail of every random number that was ever, asked for, I could have just put in some code that wrote something out to a log. And, it goes on from there. Or we could have just said, I wish I could do this to Microsoft programs, Paul. I firmly believe that the uncertainty principle is deeply implemented inside of Microsoft code to the extent that you'd think that they use the random number generator frequently for the response you get. And if that were the case, I could just eliminate that by re-implementing the random function call. I'm going to actually investigate that on the Windows side. But I think you get the point, folks, about what we can do then, because we're intercepting that function call, and we can do anything we want in addition to going ahead and calling the actual function that was anticipated. There is a way, I don't have that in my demo to show you, but there's a way that we can go find the real implementation of rand and call that from within our preloaded version of rand. Let's see here. So there's one other thing, though, that comes up, and a couple of you already alluding to it. Yes, since the LD preload is an environment variable, then sure, users could get rid of that. So we're not going to be able to use the LD preload environment variable to control what root users do, because they could just wipe out anything that we have set in our exports. But the other thing is LD preload environment variable is ignored on binaries that have the set UID bit, binaries that run with root regardless of who runs them, as an example. But that's okay, because there's a file that LD looks for. It's in etc, and it's simply ld.so.preload, and whatever libraries you specify there get treated just like LD preload environment variable libraries, but they're always loaded first, regardless of regardless of the set UID or set group ID bit, regardless of what's in LD preload and so on. In fact, they get loaded before stuff in the LD preload environment variable. And these shared libraries are implicitly trusted. So the loader's always going to load those, and that's really what we have to use in order to get control of what root users can do and intercept stuff that they might be trying to do. So would it be valid to use sudo and LD preload? Yes, absolutely. You get the best of both worlds. This gives you control and audit at the command line with sudo, and it gives you control and audit at the system level with however you've implemented LD preload. But Paul, it's not practical for your typical Linux admin team to implement a lot of LD preload stuff, right? I mean, we're talking about C programming, we're talking about a fairly intimate knowledge of the kernel and system calls to it, and I mean, it goes on and on from there. This is not a simple undertaking the way a sudoers file might be.
Right. It's one of those functions or capabilities that's out there which anybody can use, as you know, right? Because you just went ahead and made your own example. So first of all, you need a use case for it, and then you need a certain skill level. So your new, more junior admins, it's definitely going to be a little bit out of their reach. You need to be more of the mid-level to expert admin to really create stuff. And then it really just depends on what your use cases are. Like, yours is a simple example. Yeah. There are plenty of people out there that use LD preloads, but I'd say the most common use is by application vendors themselves. So, obviously, we're on this webinar with you, so it goes without saying that BeyondTrust leverages this to provide some pretty cool security functions. But, we have a team of developers working on some pretty sophisticated stuff around security. And again, just to be clear, as we're talking, LD preload with sudo, that's, that ties back into that security world, but there's a lot of different places you can use LD preloads, and for, simplistic or, things that just provide added benefit to the users. Like, I know one of the questions that came up, or a question has come up a few times, is what's to stop a user from just clearing the environment variable, right? So from a security perspective, it's not too hard for somebody writing their own LD preload or a application vendor such as, ourselves to stop someone from doing that, right? That's, you would actually want to do that in a security aspect. But if it's something that provides some sort of benefit to the user, why would somebody want to clear or turn off something that actually makes their life better or easier? And I'm being purposely generic because, again, there's a million and one different use cases for LD preloads. But going back to your question of how many people actually use them, it's people that develop their own, it's a very small subset, or the ones that do tend to be very simple use cases because, like you say, you need to be a coder for a start in order to write, some libraries that then get loaded, and then it's not just writing them, it's, making sure that they don't break or stop at other things, particularly when you start dealing with security, right? It's for us, developing our LD preload security tools, developing them is actually pretty straightforward. The QA aspect, making sure that across all systems with all users and all the applications that can make calls that rely on security don't get broken. So that's really what scares people away, is just the effort to actually leverage the capability.
Yeah, you're taking on a lot of responsibility. Okay, so here's the thing, though. We still need centralization. We need centralization for Sudo. The same thing is needed if we're going to be doing system-level control. How do we define consistent Sudo policy and LD preload policy against many different systems and get the right libraries where they need to be? How do we deal with this with different distros and different versions of Linux? And how do we centralize all these audit trails? So whether we're using Sudo or doing something in LD preload, we need to get these audit trails, the logs and the sessions, off the system where they are generated onto a separate isolated system where their integrity is not vulnerable to the very people that we're trying to protect ourselves from. And that's where you guys come in. So like I've said, BeyondTrust, PowerBroker for Linux and Unix is like Sudo and LD preload on steroids. It's more powerful, it's centralized, it's consistent across distros, it's higher level because you don't have to understand LD preload in order to use the Advanced Control and Audit feature that you've got in there. But basically what you're doing is you're trapping file system related library calls and then allowing, disallowing, or auditing those. And you can specify operations on those files and go from there. And I bet the very first file that you protect is the ld.so.preload file. Am I right?
Sorry, was that aimed at me?
Well, I was just thinking, the first thing they've got to do is make sure nobody goes into the ld.so.preload file under Etsy and change that and just try to take you out, right?
Yeah, for sure. Yeah, like I said before, for any sort of security tool, I mean that's what we do. For anybody that's developing their own security spin using LD preloads, then yeah, that should be like a number one consideration. Number two consideration is thorough QA to make sure that you're not breaking any of the normal system calls with whatever functions or controls you've implemented. So, but yeah, you're absolutely right.
All right, so let's have a look at it, Paul. Let's actually see an implementation of this. I'm going to make you the presenter.
Okay. Well, I got a few slides to go through first, if that's
no
okay.
problem. Yeah.
I'll do my slides quickly though, so that people don't get PowerPointed to death. All right, so Randy, tell me if I'm not presenting, but hopefully we see the intro slide.
You're 9x9 or whatever they say.
Okay, all right, sounds good. All right, so really just to pick up from where Randy left off, I'm going to do a couple of slides just talk a little bit about BeyondTrust and what we do from a security aspect, and then I guess we'll go into the real world application, or at least I'll be able to demonstrate how we leverage an LD preload. Although for us it's all behind the scenes, but what it kind of like gives you from an end user perspective. All right, so for anyone that doesn't know, and I'm guessing a lot of people have been to these joint webinars before, PowerBroker is the least privileged or privileged account privileged access management, however you want to look at it, platform from us at BeyondTrust. We do a lot with privileges across the enterprise, not just focusing on Unix and Linux security. We obviously do enterprise password vaulting, so taking like your root password, putting it somewhere safe and securing it. It's really important with what we're talking about today. Obviously, when we're talking about least privilege, right, is we're talking about not granting people direct access to root. Obviously, a replacement for Sudo, which we'll get into in a little bit more detail. But in any case, we have, we cover the broader picture, not just on Unix and Linux. We do Windows and Mac as well. We actually do networking endpoints for anyone that's really interested. But again, today we're focusing on server privilege management and in particular Unix and Linux. And specifically, actually, we're going to go really precise, I guess, today, and that's focusing on leveraging an LD preload or increasing security effectively beyond what somebody just types at the command line. Okay, so a little bit about PowerBroker for Unix and Linux. It is a Sudo replacement. We're not going to go through all of the capabilities of this today. Again, we're going to focus more on that where, where does it make sense to leverage an LD preload, or, how leveraging that LD preload can really help you do some cool stuff around the management of privileges. But effectively, the high-level pitch for PowerBroker Unix Linux is very similar to what you'd get with Sudo, right? Is eliminating the sharing of privileged credentials. That's really bad. I tell people all the time you should never be logging on directly as root unless it's a very, very, very select number of use cases. And I never like to say never, but it's really something you don't want to be doing on a day-to-day basis. Tracking, logging, auditing activities. Obviously that's the big thing, is if when you're handing out privileges, knowing who's using them, where they're using them, and how they're actually being used. And for us, system level control, again, going beyond just what you type at the command line, looking at what the system's actually going to do, not just controlling that, but auditing that information as well. So again, I'm going to show you what that looks like. We're going to go very quickly through this. I know somebody said, is this a bashing Sudo webinar? And it's really not meant to be. I know Randy addressed it. I think I put a short answer in the questions, or an answer to one of the questions. Again, I will tell people all day long, I would much rather see or hear of people using Sudo than sharing the root password. And for some people, Sudo will always be enough. There are some limitations that we run into, and I'll be honest with you, these are a couple of very high-level points. They're not even me trying to bash Sudo. This is just what we hear are the concerns of our customers, the people that buy a commercial solution to replace Sudo. And again, I don't want to spend time really trying to knock Sudo. I'm just saying, for some people, Sudo isn't enough. And again, we're going to touch on some of the reasons why in terms of functionality. So this is a bit of a marketing slide, so I'll go very quickly through this. Again, the features that you get with a commercial solution, auditing and governance. Okay, so Sudo does auditing, we do it to a higher level. Fine-grained least privilege. A Sudo policy is very much who, what, where, and when. We can go a lot deeper in terms of how we actually look at the requests come in and decide on whether it's going to get processed. That next one is we're going around the circle, remote system and application control. It's kind of a nice feature. Sudo works on is host-centric, as in when you type sudo command, it runs on that particular host. PowerBroker actually allows you to run that command on a remote host. Doesn't even need SSH. So from a security standpoint, you can say, hey, go and run this command at a higher privilege level over on a remote host. Dynamic access policy just allows you to reference external repositories like LDAP or Active Directory or local files, do a database query in order to grant or deny privileges. Moving on around the puzzle pieces, file and policy integrity monitoring. It's really important actually for a number of reasons. Even when we're talking specifically today about the LD preloads, when you grant somebody higher privileges, anything that they run at that higher privilege level, or even the utilities themselves that actually grant those higher privileges, you want to make sure they've not been tampered with. So that's what we refer to as file integrity. You're basically saying, make sure this hasn't been changed. For example, for people that are familiar with Sudo, you want to make sure that the Sudo binary itself hasn't been tampered with. You want to make sure that your Sudo as policy hasn't been tampered with, especially with Sudo because it is stored typically on the host where you're actually running the Sudo command. But more importantly, if you type Sudo, let's say Sudo su, you want to make sure that the su binary hasn't been tampered with, or any other commands that you may potentially elevate. And then, having some decent reporting and threat analytics, being able to take all of that data, which, we all know that once you get above like 5 systems, the amount of audit information that you generate with a tool, even like Sudo, you need something that can digest that information and give you meaningful reports or actionable items in order to make it worthwhile. Okay, so centralized by design. I think there were a couple of questions or maybe statements made in the questions that you can centralize Sudo stuff, right? So you can take your Sudo as policy and you can put it in LDAP. Yes, you can rsync or use syslog to send off audit data to other servers. It's all very true. It just basically increases the complexity of managing Sudo. I know as I say that, there's going to be some people that say, It's not complicated, but there's a wide range of skill levels in terms of people out there managing networks, and for some people it's extremely challenging, or other people it's just extremely problematic. Trying to get things just working is just difficult, right? So I think I just saw a question in that came up that said, is there support for centrify DZ-do? So DZ-do is a replacement for Sudo. It's a centralized product. For us, it's PowerBroker for Unix and Linux, or rather than DZ-do, for us it's PB Run or PowerBroker Run. We're absolutely a direct competitor to centrify in this regard. Again, I'm not here to knock the competition. I'm just going to tell you that the specific capability we're going to look at here today, using that LD preload to control effectively root level sessions, doesn't exist in DZ-do. I don't actually think any other commercially available product. So in any case, going back to these slides, we're centralized by design, always have been, makes it much easier and much more flexible in terms of setup. And again, I don't want to dwell too much on some of these slides. This is the important, I say the important slide, this is very pertinent to the topic of today. Advanced Control and Audit is the feature that we refer to in the product that ultimately under the covers is leveraging an LD preload. So our library that we put in place allows you to do a lot more than just looking at what somebody types at the command line. So again, with Sudo, when you type Sudo command, it's effectively whatever you type. With our Advanced Control and Audit, we're looking at things that the system's actually going to do. That provides a whole bunch of features, such as being able to view what's going on inside of a script. It gives you complete control over the file system, file and folder access. So for anyone that hears that says, well, I can do that with native file system permissions, you're right. We basically centralize that, right? And we do it based on policy. So we can say, if you are user Randy, don't allow him to go into /home, for example. Or if Randy elevates to a root level session, keep him out of /company confidential, because we don't want him looking around in there and seeing all of our confidential information. And again, I'm going to show you that here in just a minute. Obviously, blocking malicious and tampered binaries. Again, doesn't matter how they're called. I'll probably just get to demonstrating that here in just 1 minute. File integrity monitoring, I've already talked about. This slide goes into a little bit more detail, but it's really just, hey, look at the file name, the hash of the file, the ownership, UID, GID, permissions, location, that sort of stuff. Really just tracking important stuff on your system to make sure they've not been tampered with. It actually comes bundled as part of our solution. If anyone's looking at that going, hey, it sounds just like Tripwire, you're absolutely right. Tripwire is obviously a full-blown commercial FIM type product. I'm just saying, for anybody that's concerned about security, don't forget the importance of FIM, because if you're going to control who's elevating what, you want to make sure that the what is basically not been tampered with. It's very very important. All right, and I've already mentioned reporting, forensics, that sort of stuff. It's one of those big differentiators between a free product like Sudo and a commercial variant. Again, I'm not here today to talk about reporting. I just wanted to make people aware that that's something that you get with a commercial solution, not just from BeyondTrust, but really any other commercial solution, to be fair. And then I won't, this is the last slide, I promise you, then we'll switch over to demo. So somebody actually posted the question, where does the log information get stored? I can tell you, at least from the PowerBroker standpoint, effectively we split the client and, again, if we're going to relate this to Sudo, the sudoers file and the audit information are referenced and written directly to a different server. So for us, we have policy servers or log servers. So basically, when you make a request, I'm just going to move my mouse overhead. I don't know how well it'll work over GoToMeeting, but whenever you type effectively Sudo, for us it's PB Run, that request goes to a separate server. It will check the policy file here to say, is Randy allowed to run this command at this date, this time, and whatever other things you want to put into your policy. It will write an entry into the event log. So it says that Randy made a request for this, at this date, time, and it'll also basically log whether or not it's been approved or been rejected. And then optionally the session recording, so that's like turning a video camera onto Randy's screen when he requests elevation. That also gets recorded to a separate server. It's written directly to that separate server that gets indexed and is searchable via, you can search it via REST. We've got our own web console. You can export it. You can send that data to a SIM. I'm actually going to demonstrate some of that as well here in just a second. The important thing is why that session recording is taking place. If for some reason we can't communicate with a log server, and you can have many for redundancy, same with policy servers, then your elevated session is automatically terminated back on the client. And then all of this data can obviously be fed over to our own Beyond Insight. It's basically BeyondTrust SIM, or you can send it off to any other SIM, such as a Splunk or an ArcSight or whatever it is you want to use. All right, so that was about as quick as I could get through those. I apologize for boring you with more slides. So let's take a look at what some of this actually looks like. So I'm going to hop over into my lab. I'm going to start in a Windows box, not for any other reason than a lot of people do this day to day. Any SSH client for us is good. I'm going to use PuTTY because, again, it's a very common or at least known SSH client. I'm going to pick on, in my lab, I've got like 3 main servers I use. They're nicely named Server 1, Server 2, Server 3. Just for everybody's benefit, Server 1 is my central server that holds the policy and the log stuff. Again, you can have multiple servers. It's obviously just a lab. There's a few other servers hanging out in here, like I've got an Oracle database server and some other machines and a Mac and that sort of stuff. But just to keep it simple, we're going to focus on these 3 servers. So I can pick either Server 1 or Server 2. We'll go for this one in the middle. I'm actually logged on to this. Let me just get a command prompt. I always like the fact that Who Am I works, actually originated on Windows, believe it or not. So Who Am I, you can see I was logged on to this Windows box as a user called Demo1. I apologize for being completely unimaginative with my demo users. I got automatically signed in because I'm using the BeyondTrust AD bridge. Not that that's what we're here to talk about today. It gets me logged on as just a regular user called Demo1. Actually happens to be my AD-centric user. But in any case, I'm just a regular user without a whole lot of permissions. Now, the whole reason for really talking about LD preloads in this presentation today is even though Sudo or even our own products, other commercial products allow you to get very granular with privilege delegation, right? So who's allowed to run what commands? What we find most people do is they say, all right, I know I don't want people logging on directly as root, so we'll allow them to do like a sudo su, which basically says I'm going to audit the fact that a particular user, we'll use Randy in this example, or Demo1, wants to start a session as root. I don't want them to have the root password, and I want to record the fact that this user has basically taken root level privileges. The problem is it's very easy to write a policy to do that, but then how do you control what that user does when they effectively become root? So you've audited the fact that you've given them all of this power, but you've basically given up all control. Yes, you're going to have some auditing capabilities, which, depending on your forensic skills and ability to look at what's going on in the logs, you may or not catch when people are doing bad things. So that's really what the whole LD preload stuff is going to be about, right? So I'll start by just doing a PB run show. So here's a list of things that I can do, just at a very basic level. Obviously, if I do Who Am I see the user is Demo1. For me, if I want to run that elevated, I just do a PB run Who Am I just to show you some of the things that we can do. You don't have to do all of this, and I output some information to the screen just so you can see what's going on. I can come up with a risk score based on the command. That risk score can come from the host, the user, the command, come up with a risk activity, and then associate a risk level with that requested command. The important thing here, though, is that the command was actually authorized by a different server, Server 1. It says I'm going to run that command as root, and then the output is root. Okay, so all I've done is elevate the Who Am I command. Do exactly the same with sudo. I say exactly the same. You wouldn't be able to do some of this clever stuff, and obviously it's normally looking at your localized sudoers file rather than a centralized policy file. But ultimately, you could achieve the same thing: run the Who Am I command as root. But like I say, what most people do is they want to elevate an entire session or shell to run as root. So in this case, I'm going to type pbrun bash. And just for everybody's benefit, this is exactly the same as doing a sudo su, right? We allow you to basically call commands in any way you want. Personally, I think this is more appropriate because I'm saying I need a new shell. Bash is my shell of choice, and my policy actually authorizes user demo 1 on server 2 on Thursday at 2 p.m. Eastern time to request a bash level shell at a higher privilege level. So when I run that, again, I output some information just to kind of like show what's going on. First of all, it tells me that my session is being recorded. In this case, it's being recorded over on server 1, like I told you. We've got the file that's being recorded has a date and time stamp of right now. The server I made the request from was server 2. The user that made the request was demo 1. And the command I used to get the elevation was command bash. So now I'm here. I can type, who am I? And I see that I'm root. I can type ID and see that I'm a true full root user. So I've actually elevated the user and the group to UID 0, GID 0. I'm basically a true root user. So I can run a whole bunch of commands. I can do things like date and cow, doesn't really matter what, right? I just have this root level shell. So first of all, I'm going to head over to root's home folder because obviously I can do that. I've got root level permissions. And in here, you'll see that I've got a predefined symlink, effectively a shortcut that points to reboot on the system. So if I try and run that symlink shortcut, try and run that command, I basically get permission denied. So I'm, as a user, thinks, well, that's a little bit odd. Let's just try and run it directly rather than using the symlink. And again, I get permission denied. So this is basically that LD preload that we put in place controlling the reboot binary. It's really what's going on under the covers. If we take a look at the reboot binary, you can see it's owned by root. In fact, everybody has execute permissions, so it's kind of odd. As a user, I do have full rights to run reboot, but for some reason I can't. Well, obviously I've blocked it because even though this is my lab, I use this for doing demos and I don't want the system being rebooted in the middle of the day. So I've actually got policy in place to say, don't allow this system to be rebooted by somebody even running as root, during business hours, or in my case, during demo hours. So this user, it's not the most advanced admin, but he's smart enough to say, okay, well, I've got an idea. I'm going to basically create myself a new user called root2. And he's going to go in and maybe change his UID and GID to 0 to trick the system. Now, when he does user add, he then sees no such file or directory. So again, he tries to run user add directly. I'm really just showing you the same thing over and over, just in different ways. We're seeing all the same thing, right? Let's do a listing of user add. Again, we'll see that user add is there, owned by root. Root's got execute permissions, but again, I'm blocking this user from adding users as well. Doesn't matter how it gets called, that user add is going to get blocked. And I'm going to show you a few other ways in which we can call this as well in just a second. So let's just say, okay, this guy gives up and says, well, you know what, I'm just going to reset the password on the root account. And again, we're going to see the same thing, no such file or directory. It's because basically when you try and call it that way, I'm really getting permission denied because, again, I've blocked a number of things, right? I've blocked the reboot command. I've actually blocked the shutdown command, user add, password. And again, it doesn't matter how it gets called. I could rename user bin password to user bin Randy, and wouldn't matter. No matter how I try and call it, the system function that's actually being called is the password reset system function, and that's what I've blocked in my policy that gets loaded with that LD preload. So basically, as this session started up, those policies are in effect now for the entire length of my session. Even if I was to spawn child shells or whatever, which I won't bore people with right now, that's it's still going to get blocked. Okay, so I said we can block it regardless of how it's being called. So let's head over to my scripts folder. So this is a very typical thing where people say, hey, I've got to run this script, I've got to install this program, I've got to upgrade this application. I need root level permissions to do that. This is a bit of a corny example, I admit, but here I am in my scripts folder, and I've got a script called demo script 1. For everyone's benefit, I'm going to show you what's inside that script, although if I was malicious and I'd probably try and sneak this script onto the system, run it, and then remove it without actually displaying what's in there in my session so it would get seen, but you'll see inside the script, we do a couple of things. We basically pipe the output to dev null, so we don't display anything to the screen. But in here, we're going to try and do my user add inside the script. A couple of other things. We're going to take a copy of the password file. There's a reboot in there as well to try and reboot the system. I don't know why, but it's in there. And what I'm going to do before we do anything, I'm just going to go ahead and delete that file just so it's gone. So just to show you that if we look for that file, it's not there. It's really just going to be my proof that we've run the script. So now we can go ahead, run my script. And before I turn off echo to the screen, I print out that the script was started and the script completed. So other than the fact that I decided to show you what was inside that script, you would have no clue looking at this session as to what really was going on. If we take a look now, that file is going to be there. We can actually cat the information out, really just to show you that file did get created. So the script ran, and what I showed you inside, let's go back and look at it again. So basically, as the script ran, we know this actually occurred. We saw it saying the script was starting. We saw that the script completed. So we know stuff happened, but we also know that the box didn't reboot, thankfully, because it would have put an end to my demo. And, well, I'll actually show you the password file to show you that root 2 does not exist in this system. Just really show. I guess we should probably look for user root. So you'll see there's the root user operator, same as root. There is no root 2 user, so we know that didn't work. All right, so that's all good. All right, so what I'm going to do is I'm going to cut out of this session, just close that up. I can do this from anywhere. I'm going to jump on to, we go to this server. So I'm logged on here as a user called Amy. You can actually see that she's on server 1 called Amy. I can actually do this from anywhere, which is kind of cool. But if she does a PB run show, based on her group membership actually is how I've got it configured, she has a different set of things that she can do. One of the commands that Amy, our auditor, can do is this command called play session. Now obviously if you run play session, it's not a command that you would normally let somebody run. So type PB run play session, and what I do is basically interpret that request and present to Amy a list of sessions that have been recorded in the last couple of days. So if we look at our one today, 157, we can just pick number 1 from the menu. This is all being generated by PowerBroker, and it will basically do a replay of that policy file. So I can go through one character at a time, everything that I just did. I can move forwards and backwards. I can do a search for who am I, and it would jump up to wherever it found who am I. If I did that in the session, I can go to the beginning. I can go through a line at a time. Again, I'm really just replaying the session back to the screen. As it was recorded like a video, I'm just stepping through, that session as it occurred. Now, again, from a forensic standpoint, this could become, kind of laborious. It's also not great for, data to be digested by a SIM. So I'll just show you a couple of other things that, that Amy can do. I can do a command called list logs, and what that will do is it will show me all of the sessions that have been recorded. So here was that recording for anyone that remembered the name of the file. So Amy can actually say, you know what, show me the history of what happened inside that file. So looking now, again, this is something that all gets generated by use of an LD preload. Typically when you do session recording, people might be familiar with like the history command in Bash. For us, it doesn't matter what the shell is. What we're actually doing is we're tracking through that LD preload all of the system calls, and we're also, allowing and denying certain things. So we can actually see basically a history of what this user did. I logged on, started off in root's home directory. I ran the whoami command, the ID command, the date command, the cal command. You can see these being allowed. Down here, we look a little bit further. There was that symlink getting blocked. There was me trying to run the reboot command getting blocked. I could absolutely do a directory listing of the reboot binary. I could see it was owned by root. I could see the permissions. But all of this actually gets tracked. There me trying to do the user add. We basically see what happened. When I moved over to the scripts folder, we're tracking, where I am actually on the system. And again, all of the commands that I actually did. Now, what you'll actually see down here is, there I am running the script. So first of all, I did a cat to show you what was inside it. Now, again, this is just a history of the commands that were either allowed or blocked. Here we can see me running the script, but you can actually see what was inside that script. And I mentioned that is one of the benefits of using an LD preload to increase security on the system. So I can basically just change that with a history level 2. It's basically saying, give me a more verbose version of the history command. And when we look at that same file with a history 2, here we can see the script actually being allowed, but also what happened inside. So I ran the sleep command being piped to dev null, right? So it didn't display on the screen. That was allowed. The ID command ran in there. That was allowed. In there, you'll see the user add and the password command trying to create a user inside of my script, not allowed. Trying to reboot the system, not allowed. Obviously, there was the taking a copy of the password file. Can absolutely block that if I wanted to. I could block things. We do it at the system call level. So most of these things, this is actually just a block on the user add binary. So I've basically set no exec or don't allow somebody to execute the user add command. I could also do things like don't allow somebody to read the password file or the etc password file. That would also be pretty bad, right? Because it stop people logging onto the system. But you can do that on particular files. Let people read and execute something, but not write and delete them. So, for example, my scripts folder. Maybe I want to protect this script. Let somebody come on as root. Let them run the script. Let them view the script. Just don't let them change it. So don't allow writes and don't allow them to delete it. So they can't go and delete that script. We can also do things like making sure they don't change the permissions or don't change the ownership, that sort of stuff. All of those controls are in place. All right, so I know these demos aren't overly exciting when we're looking at all of this command line stuff. So I'm going to hop over real quick because I've mentioned one of the benefits are some of the reporting and the GUI, the prettiest stuff around some of this data. So when I come over to my Splunk application, this is a Beyond application for Splunk. Across the top, we're not going to go through all of these. I won't bore you with all of that. We got usage statistics, session audit, command audit, and we're going to look at some of these. So on the dashboard level, let's go down to, I don't know, the last 60 minutes or so. That should be pretty much what we've done in today's demo. Now, I do have some stuff that runs in the background generating data in my lab so that this has some bars to look at. So we can see, the most active hosts, submit hosts, basically where I've typed the pb run command. Run hosts, ultimately where the commands get executed, which don't have to be the same command. Top 5 users, again, it's all auto. Oh, I got demo 1 snuck in there. So there's some commands that's been done in there. Top 5 commands, nothing really exciting here. Bash, cat, date, df. Commands that are accepted or rejected. Again, in my lab, most stuff's been accepted. Down here, when we talk about ACA, this is that Advanced Control and Audit. So this is really our basically our LD preload data here. So I can actually see how the stuff that we're tracking, the majority of things are files being read, and we can dig into these just by clicking on these pie charts. What's being execed, what's being written, and also stuff that's allowed or blocked. Again, I just showed you that information over there on the command line. We're really just looking at the same stuff over here, right? So if we go to session audit, and I will apologize because my Splunk server runs on a very underpowered VM. Let's just drop this down to the last 60 minutes as well. So we should hopefully home into that session. I've only done one. It was recorded on server 1 in the IO logs folder. The date and time, if anybody remembered, it was 1:57 my time from server 2, user demo 1, and the session was bash. And there were 201 events captured inside of that session. So if I click on this particular session, we can see it was submitted on server 2. The requesting user was user 1. Obviously, these are all searchable, so submit host and requesting user. And then when we get into the actual details of that particular session, again, I kept it fairly simplistic. It breaks it down to say, hey, show me all of the stuff that was execed. So show me stuff that was executed during that session. So again, we're going to see what was allowed or blocked down here. We've got the date, the time, the directory I was in when I was doing stuff, the action here, they're all execs. That's what it's set to by default. And again, you're going to see kind of a representation in Splunk now of that user session. So I logged on, I did the who am I command, I did ID, date, cal. I did an ls-l, so I see some arguments there with my command. Down here I did an ls-l on the user bin reboot binary. In any case, we can come along and we can see everything that was exec in that session, what was allowed and what was blocked. If I want to, I could say, show me, all the stuff that was blocked. What did this user try and do in that session that was blocked by my ACA rules? So here I can see him running that symlink 1, trying to run reboot, trying to run user add. And again, all of these can be flagged and alerted on from Splunk. We can also look at things that show me anything that was read while the user was in this session. I actually didn't make any any updates effectively to any files, or else I could see, show me everything that was edited or changed on the system during that session. So again, this is everything that the user may have potentially tried to look at, files. In this case, again, I'm very focused on a small subset of things. Okay, so with that done, we'll just go and take a quick look on command audit. I'm going to show you two more things, and then we're going to open up to questions. So again, I'm going to chop the time down to the last 60 minutes. It just helps my Splunk server process this in a more timely manner. So the command audit is going to be just actual commands. Now again, I've got stuff running in the background that generates data. So in here, if we want to get more specific, I can look for just user demo 1, get rid of all users, and say, hey, what did user demo 1 do in the last 60 minutes? So again, we'll give Splunk a few seconds to try and go and generate that data for me. So I didn't do a whole lot. As user demo 1, when I first logged on, I ran the show command, pbrun show. I did a pbrun who am I, and I also did a pbrun bash. Demo 1 was to requesting user. I ran the show command without any elevated privileges. I ran who am I and bash with elevated permissions. And again, when I did the bash shell, you already have seen this. I made a session recording, which we can look at in the session audit page. Going through all of this, we generate a whole bunch of stats and statistics. We're just going to go ahead and look at some host activity, just again to show you how you can dig into some of this stuff, how you can see where you can use this to do much speedier forensics. So for example, I can come in and we can pick on, I don't know, server 2, as that's what we were looking at. And we'll let it go ahead and generate this. So here's all of my users that are generating activity on there. This one here, demo 1, there was just a spike in what he was doing because I was just logged on as demo 1 doing stuff. And again, I can click on the user here. I can click on him on the chart and say, hey, show me what was actually going on down here. Again, by default, we're going to exclude the ACA data, but I can see everything that happened in there just by turning that on, and now it'll basically go and grab all of that ACA data that occurred inside that session. So anytime there was like reads or writes, there's a lot of stuff in this session that's going to get logged. And again, I can tie this down to, just user demo 1. We do that, and then we'll just see that user's activity on this host. Now again, haven't done any demos using user demo 1 yet today. So here he is right at the end. Again, I can drill into his activity and maybe turn off our ACA stuff so we can see, what did that user do during that session. And again, we can look at individual users with user activity. That's probably not going to be a great one to look at today. Let's just go and look at rejected commands. This is the stuff that most people are looking for. What's the system being used to actively block? Maybe we've got to go back a little bit further than 24 hours because I've not done anything that was blocked from a command perspective. And in here, you're going to see the number of iterations that somebody's done something that's been blocked. Like I probably blocked the cat of the host file, and then we can click on that and see all the users that have done done that command that's been rejected. Okay, so again, this is we're just touching on specifically the benefits you get by using an LD preload. Just to recap, all of those controls I had during that session, blocking the user add, blocking the password command, blocking the reboot command, that was all basically done because I had a true root session. So I had a bash shell that was run as root. To be fair, it's not like a root user logging on, because that LD preload gets put in place that puts some constraints or controls around that root user's activity. So that puts the controls in place, But what it also enables is us to capture a whole lot of additional audit information, such as, what happens inside the session, what happened inside the script when I ran that script, and allow you to take all of that information and send it off to really anything that can consume syslog data. But in this case, I'm showing you what it looks like going to Splunk. And again, this is a free app that you get. You can take this and manipulate it to digest the data or show the data in any way that you want. This is, like I say, the common things people want to do is they want a high-level view of what's going on in my enterprise. They want to be able to dig into to sessions, what people have done during a elevated session. They want to look at what commands are being allowed or blocked. They want to get statistics on all of the events that are occurring across their enterprise. Look at what's been rejected. So what are people requesting that's, the policy is stopping, to determine if they need to add that to their policy or if somebody's just trying to do bad stuff. Analyze a user. I'm interested in what user Randy has been up to. So, I can then go and interrogate user Randy or what Randy's been doing on particular hosts if I want to get specific. Or show me what's happening on a particular host. I've got a database server. I've got a web server. Show me all of the privileged activities that have occurred on this box within a certain time frame. And again, just what we give you out of the box. Again, this is just one example in which you can take that data that's being generated and, in large part thanks to what you're actually able to capture with an LD preload is what makes this type of information really possible. So I know we've got I guess a little under 15 minutes left, so I will turn the webinar back over to Sarah. I think she's got one poll. I don't know if Sarah's going to do it or Randy's going to do it. But
No, it's me. There's the poll, and we got lots of questions, Paul.
Yeah, I was trying to fend some off during when you were talking, but it's very hard to read the questions, answer them, and present, as you know. So
yes, no problem. So let me throw some at you, okay?
Okay.
Let's see here. Christopher would like to know. Actually, let me go to Paul's question first. Will Sudo work while performing yum updates?
So can you use Sudo to do a yum install or yum update? Absolutely. Yeah. I mean, it's
I think that's what he's asking.
Yeah. I mean, in respect to an LD preload, you could allow, you could make an LD preload that lets somebody, well, I guess you could do it from Sudo policy as well, but just for a fun example, you could make an LD preload. So even though your Sudo policy might let anybody run anything, you could use an LD preload to say, let somebody do yum update, but don't let them do yum install, or even maybe a yum uninstall, or certain switches you could block from yum to stop people removing stuff that's been installed on the system. So again, you could let somebody do, I guess more realistically, you would let somebody do a sudo su so that they've got a sudo elevated root shell, and then use that LD preload then to control yum activities within that root shell, so you don't have to get all granular inside your policy. But really the root of the question is, can I control yum with sudo? Absolutely. In the same way as you could use pbrun, or even, as I've seen DZDo show up a couple of times, you could use centrify to do the same thing.
Christopher asks, is the forensics part of the analytics mentioned?
Yeah, so again, it's really hard to cover everything that we have the capability to do. It was really to try and highlight a little bit the differences you get with a commercial product versus Sudo. Again, I'm not here trying to knock Sudo. I'm really just pointing out some of the differences. You may say shortcomings. I think it's perspective, right? How much control, how much audit is important to you. For us, when we talk about PowerBroker, or particularly PowerBroker Unix and Linux, everything we have is included with the product, right? So even though we didn't touch on 95% of the features, things like the FIM stuff that we include, you get that, all of the reporting, the Splunk application. I can't think what else. It's everything. The ability to indexing, right? So when we talk about forensics, just being able to go and view the log, log data is one thing, but having that indexed and searchable is highly important. Again, something you're not going to get with Sudo. Yes, I guess you could syslog it, send it to Splunk, and then use Splunk to do the indexing. In much the same way as I've just shown you, the information is just richer and more detailed in a commercial solution. But yeah, hopefully that answers that question.
Okay, we've got a bunch more. Brian says, how is this employed in very dynamic cloud-centric environments where host instances are short-lived? It's a good question.
That's a fantastic question, and one I've been getting a lot over the last couple of years. And interestingly enough, me and Randy were just talking about the mass migration to the cloud before we started this webinar. So the way it works for PowerBroker, at least, is in terms of licensing, I guess, is probably where that question is concerned. We will basically license a host for a short period of time. We have control down to a minimum of a day. So I know instances are short-lived in the cloud environment. Unix servers tend to be slightly more long-lived. The most dynamic environments I see, they're typically, unless it's for testing, a server is going to stick around for normally at least about 5 days. But basically, if you use a host for 1 day, we'll track it. When it goes away, we'll free up that slot for a new host that gets provisioned to just take over that other one. It's all dynamic UUID licensing, so all of that's catered for. As far as the back-end server component stuff, the policy server or servers, the log server or servers, they can be on-premise or in the cloud, or however you prefer, so long as they can communicate with each other over a single port. It's just a straight TCP port. They can also be dynamic as well. Like you can elastically add additional log servers, and they just come up and they will self-license, and actually they can self-register, and we use something called registry name service. You can use DNS if you prefer. You can use static lists as well if you want to script it. But you can add and remove components at will in order to deal with load. Again, it's just going to be a cost/resourcing type deal. So I guess maybe a shorter answer to all of that is we're just a host-based application. So for us, we don't care so much whether you're running on-prem, cloud, hybrid, whatever. It's just a privilege elevation or management tool that sits on that OS. But we work just as well in dynamic environments as we do static environments.
Okay, Tomas asks, what happens if the policy or log server is not available?
Yes, that's another great question, and one that I've had maybe a million times. So we're very, I guess, fault tolerant or HA capable. Now, by default, we run in a mode whereby we expect there to be a policy server or log server available. So again, you can stand up as many of those as you like. In a typical implementation, I would normally say if you've designed your implementation correctly, if a policy server is not available or a log server is not available, you typically have bigger problems, right? Because you're suffering some bigger outage that letting somebody run something at a higher privilege level for a short period of time is maybe not your top priority. We do have some fallback mechanisms whereby you can enable somebody to basically still elevate even though we can't get to a central server or a log server. I normally recommend against that from a security standpoint. It's best to basically say, if I can't communicate with a policy server, don't allow somebody to have those higher privileges. Absolutely, if we can't log it to a safe, secure location, again, block somebody from having those privileges. It's very designed fault tolerance so that there should always be at least one, but preferably more policy/log servers available. In the most extreme cases where they have, where people have the possibility of network problems, I guess, stopping the access of other servers, you can actually make every server a policy/log server. Effectively, at that point, you're kind of running in almost like a Sudo mode, where if I can't communicate with a network-based policy server, log server, then the fallback option is to use the localized policy/log, which might be, much more restrictive if you're sensible about security. Again, not an implementation I'm particularly fond of, but it's really down to what the customer wants.
David asks, when you run pb run bash, does it pass the profile of root for variables and so on?
Oh, that's a great question. I love that one. So we effectively have, when somebody runs a request, and this again, it's one of those big differences between like a Sudo and a commercial variant, or particularly the PowerBroker variant. We basically kind of like split the request into two things, right? So there's the actual request itself. We look at the environment, so that will be things like the command that you're requesting, in that case bash, any arguments that have been requested, and anything about the environment that's being requested. And then when we basically perform the elevation, we can be very selective on how we manipulate what we call the run environment. So we can say, I requested command X, but I'm going to run command Y. That's the most simple example. But we can choose to alter. The only thing we alter would be the command that actually gets executed, or not alter actually if you just want to let it run. But we have full control over the actual runtime environment. So you probably noticed when I did a PB run bash, you saw the background color changed and the font went to red, really just highlighting that I'm in a privileged mode at that point. That's because PowerBroker has the ability to manipulate anything about that user's runtime environment. So not just environment variables, but we can specify the run user. So that's going to be root. We can also choose whether we manipulate the run group, so the user's primary group, the run groups. Any environment variable on that system can be manipulated. We can also, before we allow or deny a command to run, we can really manipulate anything on the system. So we can write to a file. We can go in, we can send an email. We can generate an alert that gets put in syslog. So I guess what I'm trying to say is we can do as much or as little as you like. So we can completely alter everything and lock down that user's runtime environment. Or we can say, the only thing we're going to change is effectively the run user, the run as user. And that's everything would be as in the same environment state as when you type pb run bash, other than bash is started with a run user of root, or we use root all the time, but it could really be any privileged user.
Richard asks, are there general policies to work with? I bet he means like pre-built policies.
Yeah, we got a number of default policies. Well, there's a default policy, and we've got a whole bunch of examples. I'll be honest with you, like one of the reasons a lot of people like a solution like PowerBroker, and I'm really just repeating what my customers tell me, is the amazing flexibility of what we can put into our policies. So one of the ones that I like showing people recently is ServiceNow integration. So when you type pb run bash, we can say, hey, you need an open and valid ServiceNow incident that is a priority one that's assigned to your group or assigned to you as a requester, and it will actually go out, validate that incident number against ServiceNow, and assuming that everything checks out, it can even update that ServiceNow ticket with the session recording file name and other information. You can actually use it to open tickets. You can use it to update tickets when you're in the middle of a session. All of that is you can build all of that into our policy. And again, we give a lot of examples, but really it's down to whatever use cases you can come up with, or functionality you want to do. If you can think it up, chances are we can do it with PowerBroker.
Awesome. Let's see here. Okay, I love this question from Robert. Does this apply to downloaded or transferred files as well? And I think he's talking, at the time he asked that, you were showing some executable like reboot that you were running.
Yeah, that's actually a really good question, because again, it doesn't actually matter what you've downloaded or copied or FTP'd or WinSCP'd, whatever you've done to get a file onto that system, wget, right? You go get some sort of binary. It doesn't matter where that binary comes from or even what it's named. It's ultimately the system call that it does. So when I was showing reboot, for example, you could download a binary from some web server that's called command X. And if command X basically runs the system function of a reboot, the fact that our policy says don't allow reboot to run, that's going to get blocked. I kind of tried to show that by running a script and running the symlink, but again, it would apply equally as well to if you've downloaded some rogue file from the internet. So when you say, I don't want the system to do a particular function, and again, we were focusing very much on execs, but we can limit things, like I say, writes, reads, writes, change of permissions, change of ownership. There's about 14 different file system calls that you can basically bake into your Advanced Control and Audit policy.
Yeah, in fact, when he asked that question, I quickly wrote a reboot RFS executable, but I was going to send it to you just to demonstrate this, but I got some segmentation fault in the thing. So, but that's really the thing, and I think it's, we're tempted to say, oh, if the person runs the reboot command, but what we're really saying is if they do anything that calls the reboot syscall.
Yes. Yeah, that's really, again, it's a huge difference between things like, I always feel like I'm bashing Sudo, and I've been trying really hard not to do that. We stick with Sudo for right now. Sudo is basically looking at what you type on the command line after the Sudo binary is, or the Sudo name is typed. An LD preload allows you to look at what the system itself is going to do, which, like I say, is often the same, but doesn't have to be. And if ever you're looking at a way of tricking a security tool, like all the clever admins I've bumped into in my life, that's normally what they're doing, right? They're using not overly complicated things like, I know my Sudo policy allows me to do X, Y, and Z, so with a simple move the binary to a different location or move what I really want into this location and rename it, and I can do whatever I want. That's really the difference that an LD preload / commercial product that has those sort of tools or granular permissions built into it is going to give you.
All right, we still got about a dozen questions. Wendell asks, okay, so if you're using PB to limit root's ability to reboot a server during business hours, how do you address that in a situation where it's imperative to get it rebooted during business hours?
Yeah, that's a good question. And I know that we're running a little bit over, so I'll try and keep my answers short. I would say if you want to dig into more detail, we always do a follow-up, right? But effectively for us, we have our password safe product, which is a credential vaulting system. You could always go and check out native root and say I'm in a Sev 1, Priority 1 type situation. I have to get on as native root, basically bypassing all controls, but give me full root power because I have to restart that server. Other things you could do is you can, within the policy, you could say if somebody's elevated a root shell, I showed you just a straight, yes, it's alive, no, it's not. We could even do things like when somebody does a reboot, they have to enter a one-time password from like a two-factor token, or even have two managers basically provide two independent one-time password codes, whatever you want to build into your policy to say I need to bypass this, but take it out of the hands of just one admin who, for whatever reason, thinks it's okay to reboot a system without authorization. You could build that into your policy just as easily.
All right, Tomas, if the script was compiled into an executable, will PB stop the not allowed activity? And I'll just take that one real quick. The answer is yes. In the stuff that you're doing with LD Prelude, because again, it all comes down to the system call at the end of the day, and that's what we're intercepting. And that's what I mean by it, calling it a choke point.
Yeah. Yeah, it's like almost like a last check or a checkpoint at the last thing before the system actually actions it. It doesn't care where the source is. If you think about border control, it doesn't care what countries you've been to before you get to that checkpoint. It's just saying, are you allowed into my country? Are you allowed to pass this checkpoint?
Okay, Simon, how are accesses and restrictions entered in PowerBroker? Is this with a template? Do you have checklist forms? You might have shown that after the question was asked.
I didn't. Again, it's one of those things of trying to be selective on what I show, so I can very, very quickly just hop down to, hopefully, let's go over here.
Yeah, this will be good to see this.
Yeah, I'm going to make this as quickly as I can. So down here, when I want to build Advanced Control and Audit functions, it's as simple as saying, what's my target? So let's just say we're concerned about /home. All right, that's going to be everything in /home if I want to do it that way. If I even care about the home folder, I could just do /home. If I cared about a particular file, I could do etc let's do XE password, something like that. Log messages, log message, type any text you want in there, it just goes into the audit trail. Ignoring some of these things here like the log level and stuff, this is really what you're talking about, is these operations here. Read, I want to allow. Write, I don't want people changing my file. I don't want them deleting it. I want them to be able to execute it. Do I care about other things like changing permissions? No, I don't want them to do that. Do I want to allow them to modify the sticky bit? No. Do I want them to change ownership? No. You basically just pick the items that you want. This is how you actually build an ACA rule, is just by pointing at a target and choosing the things you want. If you want to have more detailed login around people that are trying to do a delete versus somebody that's doing a read, you can do that. Very straightforward, and it basically builds the policy syntax for you. So once you're done at the end, this is actually the code to control stuff if you want to see it. But effectively, I just type insert at the end. And those controls are now associated with this role. This is, well, not a very good role. I should have done like elevated shells or something, would have been a much better one. Let me go ahead and ignore those changes. So in here, this is where I would put those sort of controls. I would just come here, do that ACA thing, and then say, when somebody has an elevated shell, control their access to Etsy password. But yeah, it's all basically GUI driven.
Okay, Tomas says, in such a scenario, will the entire EXE be blocked or just a subset of the actions? That's where Tomas was asking about if we compiled it. But again, it has nothing to do with the EXE. It says, what is the EXE trying to do with the kernel, Tomas? All right, next one. John says, what is the source of this data in Splunk? The event log?
I was sending stuff from... Well, actually, it was a combination of things, right? So two things. The event log is the who, what, where, and when, static information of this user tried to run this command. The session audit stuff comes from the IO logs. I say IO logs, I'm bad at that. Input-output logs, effectively. It's the session recording. So it comes from two sources. When somebody elevates a command, that goes to Splunk. And when a session has been recorded, at the end of that recording, we basically extract a whole bunch of information from the recording file and shoot that over to Splunk as well, so that I can dig in and see what happened during a session.
All right. How's PB licensed by machines managed?
Per host. Yep.
Okay, there you go, Robert. There's the answer. Tomas, is this control only applicable to logged-in sessions? What about daemons? Does it control what activity can occur via daemon?
So it depends on... so typically, PowerBroker is for interactive sessions because it does have to be invoked in some way. Now, if your process or cron job or whatever invokes PowerBroker when it runs, then all of the controls we load will still take effect. But normally it's invoked as part of like an interactive session I would say kind of like Sudo, right? You type Sudo command for us, you type pbrun command. That's the invocation of the security controls. Although they can also be done during automated processes as well.
Okay, Christopher, referring to the stuff you're showing in Splunk, he says, we don't use Splunk, we have Elastic, so does PowerBroker have any built-in analytics or dashboards?
So yes, again, in the interest of time, I skipped over a whole bunch of that. So we have a management console where you can view all of the event log data. You can deploy our Solar indexer. You can search those indexes. You can replay the IO logs. Do all of that from a web interface. You can also do it from the command line. I showed some of that. There's a full REST interface, so you can actually go and extract all of that information you want. We write it straight to syslog, or can send it to any syslog server, so it can actually go to any SIM. We've got that pre-built app for Splunk. We are actually in the throes of doing additional apps for, I think Elk is next on the list, and I forget which one's coming after that, but we're doing a number of other SIM type things. And then last but not least, we have our own, BeyondTrust actually offers their own kind of SIM. It's called Beyond Insight, and it kind of acts as like a SIM and holistic reporting for all of the BeyondTrust products. So if you have our password safe, our PowerBroker for Windows, our PowerBroker for Mac, our PowerBroker for Unix and Linux, or just one of them, you get that Beyond Insight console for free. but it actually takes feeds to, from all of our products and provides you a whole bunch of threat analytics, reporting, and everything else, but it ties it all nicely together if you have multiple products, and that in turn can also be used as a segue to send it on to any syslog server as well.
Andrew says, would this technique work for containerized workloads?
So containers are, it's more for the systems that basically runs containers, right? Because again, think Sudo or PowerBroker or really any privilege management solution. It's kind of when people are operating there at the command line in some sort of interactive session. A container is more of a, doesn't have a full operating system. There often is no shell that you're really interfacing with. If you do have a container that has a host OS in it, then yeah, there's nothing stopping you throwing PBUL or any other solution on there. But what I typically see is PowerBroker would be used to, you'd put it on your Docker server, for example, and you would use it to control who can start containers, stop containers, or create new containers, whatever Docker controls that you want to have, do from the command line. Use PowerBroker to control and audit those activities.
Simon says, or asks, how would LD preload work with respect to SE Linux in an enforced mode? So can PowerBroker update or modify SE Linux restrictions?
It can. Normally one of the things we recommend is where you have PowerBroker policy, basically you set SE Linux to allow the PowerBroker binaries to just run unconfined. The main reason being is I kind of look at SE Linux as a fairly complex policy for your system that can do a lot of stuff, but it's best designed for dealing with those process level or processes that are running on the box, whereas PowerBroker is much better at dealing with those interactive shells, and the policy is much more geared towards interactive controls around a user session, which is some of the stuff we looked at today. If you want, we can actually work hand in hand with SE Linux, but you kind of end up duplicating your rules. Like whatever you put into your PowerBroker policy, you then have to go make sure you've added to your SE Linux policy as well. So it's kind of up to you, but I would kind of recommend that you would normally just switch SE Linux to let PowerBroker do its thing and let SE Linux do its thing, and they work in like their own areas of speciality, if you like.
So Robert says, does session recording also record admin changes done inside an X Windows GUI? Now, let me just say that any self-respecting enterprise is not going to be using a GUI when they're administering Linux. I mean, let's just.
Well, I would actually say that's a fair question, and normally what normally provokes that question is people have, there's a small number of applications out there. Oracle has a couple that basically you have to do from an X Windows session. So I just go with the fact that it's one of those applications that's driving that question. In which case, yes, we absolutely record all of your X traffic. It is actually a feature as far as playback goes. You can actually play back all of that X data via our normal session recording, only it's all textual right now. We're actually working on the next generation of our web-based session replay tool, which we didn't get into today. Audits who's looking at what sessions, and you can mark them as passed, or security concern, needs review, that sort of stuff. We're actually working on something that will reconstruct a full X session as part of that replay capability. So right now, yes, we absolutely capture all of that data, and it is all there and indexed and logged. The playback tool is going to be enhanced to basically regenerate X sessions on the fly based on that data. So it's I think that's coming around about the end of the year.
All right, cool. A couple people want to know, is this LD preload ACA functionality part of the standard PowerBroker, or is it a separate add-on?
It's standard.
And Simon, installation methods. Mentioned dynamic environments. Can installations be automated, like with Chef recipe, to include the build, Anaconda install scripts, and so on?
Sure. Yeah. So we have our own management console that will do discovery, deployment, and updates. As far as the installs go, we have both a script-based installed or install script or package-based installers. So if you just want to wrap it up in a package, you install one, it creates like a configuration file or an answer file, if you like, and then you push that out. Ansible seems to be the way everybody's going to right now. We're actually working with a third-party vendor to build Ansible packages for all of our Unix Linux solutions. But yeah, we have plenty of customers that deploy the software using Puppet, Chef, Ansible, and even some other, I think satellites is probably another one that I come across from time to time. So yeah, no problem doing that.
Jamie says, where are the logs? Okay, so Jamie, that question on logs with Sudo, please check out my previous webinars, because in fact, I think we even did a webinar focused on audit logging of Sudo and what your options were for centralizing that, and that's just under webinars at my website.
I think I posted a link to that, your webinars section, in a question earlier today.
Okay.
That might be in the question and answers section if somebody is looking for the URL. Or I said just Google it. I mean, Google Randy Franklin Smith and Sudo. I think gets you there pretty quickly as well.
That is true. Let's see, and I think we nailed just about all the questions. Thank you, everybody. Oh, wait, one more. Simon asks, do you have any UBA type rules or rules to notify on mischievous, malicious methodologies?
All right, so
user behavior analysis.
Oh, okay. Analysis? I was thinking it might be anomalies or something, but we have examples of how you can do so. So actually, one of the things we're actually doing right now is as an add-on to our Splunk app is adaptive response module that will go hand in hand with our Splunk app, which is really exactly that. And funny enough, I was on a conference call this morning where we were talking over some of the things that we're building into that adaptive response app. So at the end of the day, there's variables that go into that type of function that ultimately you're always going to have to provide, right? So the main things are number of events, so number of things we allow or reject, and within what time frame are going to be the kind of user inputs. That will also then get coupled with what type of event are you looking at, an accept or reject, or an allowed or a blocked. And we do that based on user activity, host activity, or what we call ACA activity, which is that LD preload activity. So when that rolls out, that will give you a whole bunch of, I guess, examples. We actually have some that have been kind of ad hoc for customers, just to give you an idea of things that we've done and will be included in that adaptive response application, which is going to be finished by the middle of the year. Being able to block a user based on abnormal behavior, and again, you'll be somewhat responsible for defining what constitutes abnormal behavior, but block a user from elevating or using PowerBroker, block a host, either a submit host or a run host, turn on session recording for a particular user, turn on session recording for a particular host. Again, that can be the submit host or run host. Schedule a host to be scanned by a vulnerability scanner. We have our own, which is Retina, but again, it could be any vulnerability scanner. Require additional authentication for a user based on, again, abnormal behavior. So rather than just letting them elevate, suddenly start prompting for a one-time password or for them to re-enter their password or whatever. And with all of those, checkbox for email/notify, so that when we spot that abnormal behavior, not only do we adaptively change the operation of PowerBroker, but we also notify people. And again, that will all be baked into an example Splunk app, but there will be the matching PowerBroker policy to go with that. So we've done a number of those in different guises, I guess, for some of our customers, and we can absolutely work with you on providing those examples, or provide professional services to custom create your own. Or like I say, when that adaptive Splunk app comes in the middle of the year, that will also basically highlight or showcase a number of those scenarios. All
right, awesome. Well, thanks. What does ACA stand for? Advanced Control and Audit. And any interaction with QRadar?
It's the same thing. It's just we can absolutely send stuff off to QRadar. It's just a syslog receiver for us. We can choose which variables or fields, if you like, from there's about 150 or so data points that we collect every time somebody types PB run, as well as all of that Advanced Control and Audit or ACA data can also be extracted at the end of any session and sent to syslog. The only thing the Splunk app gives you is basically some nice pretty formatting and dashboards and that sort of stuff. But yeah, we can shoot that off to any sim, and if you want to build your own dashboards or queries/views, you can absolutely do that, including QRadar.
Awesome. Well, I think this really is it this time. Paul, thanks a lot for showing us PowerBroker and especially this ACA function, and for making today's real training for free possible. And folks, thanks for spending time with us today. We hope it was valuable, and we'll be in touch again soon. Bye-bye for now.